Hello and welcome. Today is day 2 in the revision for AB Chemistry 2026. This is a revision guide that you can find online. It includes units 2 to 1 and 2 to 3 content, and it has some of the unit 1 content that we have already revised in day 1 for a spaced repetition as we are doing. If you don't remember, I will repeat. This guide is decided so that you can use and revise and answer in it directly. So on the left side, there is a question prompt and the options or the place to answer the FRQ question if it's FRQ, and the detailed explanation with the answer is on the right side. So you can fold it and answer on the left and see the answers on the right, or you can just hide it with a book and then use it for the revision. So let's start with our MCQ questions for today. As I said, this is day number 2, and you can find all the files free on the website www.abchemistryrescue.com. And let's start. So the first question is saying, which type of bond is characterized by the electrostatic attraction between a sea of delocalized electrons and positive metal cores? Is it the ionic, is it the covalent, is it the metallic, or is it the hydrogen bonding? We know that the type that has these characteristics is it the ionic or is it the metallic?
Metallic.
Yeah, it is the metallic, that's correct. So in the metallic bond, we can see that there is metal atoms which lost their valency electrons, so they become positive ions like copper, 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 or iron, 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 iron. And then these electrons are moving everywhere. They don't have a fixed place. That's why we call them delocalized or freely moving electrons. These electrons, as we explained, is the reason for most of the properties of the metals. So they will explain why the metal is conducting electricity, why they are malleable, why they are even brittle, and why they also have the metallic lattice or the metallic look. So all the properties of metals are explained by their metallic bond character. So the first one answer is choice C. Which bond involves the sharing of electron pairs between two non-metal atoms? Is it the ionic? Is it the covalent? Is it the metallic? Or is it
Covalent.
interstitial? It is the covalent, that's correct. We know that in the covalent bond, there is a sharing of electrons. So I have two or more non-metals sharing the electrons between them. Non-metals have high electronegativity usually. So I have, for example, atom A and atom B. This is sharing 2 electrons and this is sharing 2 electrons. So when this share 2 and this share 2, this means they are sharing 4 electrons. So atom A is like that, sharing 2 electrons, and atom B is like that. It is sharing 2 electrons. So both of them are sharing 4 electrons. We know that every 2 electrons shared make a bond. So if we have four electrons shared, so I have a double bond. If I have 2 electrons shared, I have one single covalent bond. If I have 4 electrons shared, I have 2, which is a double covalent bond. If I have 6 electrons shared, I have 3 or triple covalent bond. The next question, MCQ, is asking, so the answer here was B, covalent. In a potential energy diagram for a diatomic molecule, what does the x-axis value at the minimum point represent? We know the energy diagram looks like that. It has a small well at the bottom or something which is a deep look. And it looks like that as in the drawing, like that. So it has a small part, which is this part location. Is it representing the bond energy? So if it looks like that in the drawing, it will go x-axis and y-axis. And there is a low point. What is the lowest point called? Is it the bond energy, or is it the atomic mass, or is it the bond length, or is it the electronegativity? What does this represent? What does this point represent? We know that the bond represents what? Represents the bond length. And we said that this is the perfect distance between the two atoms. See, if I have a hydrogen here and a hydrogen here bonded together, if they are very far from each other, then the potential energy is very high. Potential energy is high means that it is unstable atoms. Why it's unstable? They don't make the hydrogen bond. So in this case, the distance is very far. This is the distance, the x-axis on the distance. So they are very far from each other. So potential energy is high. That's why I can see number, the potential energy is here is high. Again, if they are very close to each other, like if I make them, let me draw, this is the hydrogen and hydrogen, they are very far from each other here. So they are unstable. So the potential energy has come up, right? What if they are very close, closer than needed, like they are very close to each other? The ion of this one is touching the ion of this one, it will make an explosion. This will not be close to each other like that. That's why it's unstable also. So this one is unstable and not good, and this one is unstable and not good. Why? They are very far from each other or very close to each other. So if you notice, both of them, they have high potential energy. When does the potential energy becomes low? When they are stable. And when do they become stable? When they have the perfect distance from each other. So they are not very
اه
close to each other and they are not very far from each other. This is called,
يعني كل ما تبقى فوق تبقى unstable، ولما تبقى في النص unstable برضو لازم تبقى تحت قوي،
yes,
صح؟
it has to be very low. Why it is here the lowest? Why? Because if you looked at the x-axis at this point, this is the perfect distance. This is the perfect distance. It's not very far from each other. It's not very close from each other. It's like you and your friends are sitting on the same desk. If you are sitting on the same desk and you are very close to each other, then it's very awkward, right? It's very awkward. So it's better not to be also very far from each other, because if you are very far from each other, you will not be friends. Everyone is sitting on one part of the desk and you are not friends. So what is the best thing? The best thing is to have a perfect distance. You are close to each other, you are friends, and the distance is still not very far, and it's not very close, so it is awkward. The atoms should be like that. They are making the bond, perfect distance between each other. That's why when I come from here to here, what happens?
والريست
From the right to the left, this one, it goes down. You see the green arrow? It goes down. Why is the potential? It means the potential energy is going down. Why it's going down? Because when you move from this to this, it becomes more stable. Also, if you go from this one to this one, from very close to a little bit close, then it goes down again. Why? Because it becomes stable. But if I moved from the stable to unstable, from this one to this one, what happens to the potential energy? It's getting higher, right? It's getting higher. Again, also, if I move from this one to this one, what happens to the potential energy? Also, it gets higher. Why? Because they are
higher.
getting more closer to each other. This is only the perfect place. The perfect distance is called what? This is what's called the bond length. So this is the distance between the nuclei, the nucleus of this one and the nucleus of this one. This is called the bond length. Okay, let's see one more MCQ. So the answer was C, by the way. And the next MCQ is asking me number 4. So it's asking ionic solids like sodium chloride are typically malleable and soft, brittle with high melting point, or liquid at room temperature, or conductors in the solid state. I know that
Ionic.
sodium, they are what? They are
Uh,
ionic.
Ionic.
Ionic are not malleable and soft. What is
No,
malleable
they're
and
not.
soft? They are not
Malleable, they can move. You can
malleable,
shape
can
them،
you
صح؟
can shape them, but these ones you cannot shape them. They are brittle and they have
B،
high.
صح؟
Yes, it's correct. So it's B. The high melting point. C, liquid. No, of course they are not liquids. Conductor in the solid state. They are conductor when this is wrong, right?
conductor is liquid أو aqueous. molten
Exactly.
أو aqueous.
Aqueous or molten form, it will be conducting electricity. But if it is solid form, then it's not conducting electricity.
Conductor.
So let's revise again. What is the ionic compound? The ionic compounds, as we said, is a positive ion and negative ion alternating with each other. If you try to move it, then it will be brittle. It will not change its shape. It's gonna break down. It's brittle shape. And the high melting point equals strong Coulombic forces, and brittle equals shifting causes like charges repulsion. If you remember, we said when you shift them, this is 1 plus 1 minus beside each other. What happens when you shift it? This is 1, and there is another 1 beside it like that. But what happens when you shift them? This layer, mister, will slide
They will
over this
repel.
layer. They will repel, exactly, because the plus will come beside the plus and the minus will come beside the minus. So they suddenly repel away from each other. That's why the structure breaks. That's why the structure breaks. That's why we know that ionic solids are brittle, and they have,
Brittle.
why they have high melting point? Because the attraction forces between the oppositely charged ions are very strong. Okay, which element has the largest atomic radius? Is it the F or the Cl or the Pr or the I? Let's have a look at the periodic table and
ما
see.
هو
Is it F or is it Cl or is it Pr or I? Let's see the periodic table. I have the F here, I have the Cl here, I have the Pr here, I have the I here. Which one of these has the largest atomic radius?
okay.
I know that as
الatomic radius
increases or decreases as I go down.
increases.
Exactly, excellent. So as you go down in the periodic table, the radius is gonna increase. The radius is
Increase.
gonna increase, which means that the iodine is the highest one of them. So the radius increases down the group. It has the iodine has the most principal energy levels. It has more shells, making it the largest, making it
طب
the largest
the
one.
large.
Yes.
طب across the period what
Across the
happens?
period, it decreases. Across the period, it decreases. So atomic
Okay.
radius in the periodic trend down the group, it will increase. So if A is small, this is bigger, this is bigger, this is the most bigger one. This has only one layer, right? It has
Yes.
two layers, 2 and 7. 2 electrons and then 7 electrons, 9 electrons, right? And this has 3 layers, this has 4 layers, this has 5 layers. So iodine has the most number of principal energy levels, making it the largest, and as I go down, it increases. Let's see the next MCQ. As you move left to right across the period 3, effective nuclear charge what? The effective nuclear charge as you move from left to right. The effective nuclear charge is the number of protons and then subtracting from it the two factors, the size of the atom and what is the other factor that you subtract in order to get the net nuclear charge? The shielding effect. So as you go to the right in group 3, what happens to the nuclear charge? What happens to the number of
It
protons?
increases.
It increases, yes. So as you go from left to right, the protons increase while the shielding does not change, right? So if you have sodium, let's have a look at the shielding in sodium. Sodium has a nucleus and then one layer contain 2, second layer contain 8, third layer contain 1. Where is the core electrons that are making the shielding? This one. These are the core electrons that are, what is the shielding? It is the layer which is separating the valence electron from the nucleus. So it is a shield, it's a protection between the nucleus and the electrons. What does the shielding do? It makes a layer, it makes it difficult for the attraction to happen. Why? Because too many electrons here, right? Negative, 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 causing repulsion, making the attraction less. Okay, what about the magnesium? How is this happening? It's still 2 and 8, no difference, right? What about aluminum? What about fluorine? What even argon? The shielding does not change in the same period. The shielding in the same period does not change. In the same period, it's always 10 electrons, 10 electrons, 10 electrons, 10 electrons. It did not change. So there is no effect. What about the distance between the nucleus and the valence electrons? Is it different? So this is the,
No.
no, this is the distance here. This is the distance here. This is the distance here. It is the same. So the only factor that affects the effective nuclear charge is the number of protons only, and the number of protons is increasing, and the number of
But it
protons is increasing.
decreased.
The number of protons is increasing.
Increasing. The
So
nuclear charge had decreased.
the nuclear charge is the number of protons minus the shielding and minus the distance. There is no difference in shielding. There is no difference in the distance. So the only factor which is affecting the net nuclear charge is what? Is the number of protons. And what happens to the number of protons? It increases.
ما هو
So the
it's
net charge,
increasing.
yeah, so it is increasing.
Decreases.
Why it decreases? What is the factor that will cause it to decrease?
ما هو مش حضرتك قلت when you when the nuclear charge you minus from it proton number صح؟
No, we don't minus the proton number. The net nuclear charge means, what is the means by the effective nuclear charge? It means the number of protons, the effective nuclear charge means the number of protons, but you subtract from it the shielding effect and the distance from the nucleus. distance from nucleus. Why you are subtracting this from it? Because these two factors decreases the number of protons. It's like I'm telling you, what
Oh,
is your
okay.
what is your speed? You will tell me my speed with the car. I'm moving at 100 kilometers per hour, but the road is very bad. So the asphalt is very bad and has a lot of bumps. So it decreases my speed. Like it caused a 10 kilometers decrease. So what is your net speed? It's 90 kilometers per hour. But what if there is nothing here? What if there is nothing here? Then it is totally 100, right? Here it is the same.
Yeah.
You say the number of protons is what controls the nuclear charge minus shielding. What if I said there is no shielding and no distance difference, right? We said, that's what we said here. There is, in the same period, there is no difference in the shielding and there is no difference in the distance, right? So this means that these two
Yeah.
factors are not making anything. So the nuclear charge purely depend on what? On the number of protons. Nothing is decreasing it. And you said that the number of protons is increasing. So this means that the net result is also
Is
increasing.
increasing
Is
part.
also increasing because nothing stops it. There is no change. Okay, Mr. When does the shielding effect and distance show? When they are going to show? If you are comparing elements in what? In the same group. In this case, if you are comparing lithium to sodium, to potassium, to rubidium, to cesium, in this case only there will be an effect for the nuclear, for the shielding and distance. Why? Because look at the lithium, there is 2 electrons and then 1. What about the sodium? 2, 8, 1. What about potassium? 2, 8, 8, 1. Is the distance the same in this all? No, it's getting bigger, right? So what happens
Yes.
when it gets bigger? The electron gets far away from the nucleus attraction, right? So now there will be something that decreases the effect of the protons, right? What is that? The distance. What else? The shielding. Look at the electrons that are making the shielding here. How many electrons? 2. Up here, 10. Up here, 18 electrons. So the shielding effect. So this factor becomes more if you are moving down. But if you are moving from left to right across the period, they don't do any effect. They don't do any effect, which means that the nuclear charge will depend only on the proton number. Is it fine? Let's go
Yes.
for the next question. That was question number 6. And I have a small drawing to represent it also. This is number 6. So again, as I move across the period from the left to right, the ZF, what is the ZF? It is the net effective nuclear charge. So it's the ZF or the effective nuclear charge. It increases. The moving right, the protons increase while the core shielding stays what? Stays the same, right? There is no difference. We said there is no difference. Why there is no difference, Mister? Because they all on the same layer. This one has 10 core electrons. What are the core electrons? The non-valency, this is valency, and this is core. So how many core here? 10. How many core here? 10. How many core here? 10. So as you move from sodium to magnesium to even argon, it does not change. So nothing reduces it. It only depends on what? On the number of protons. So the net pull on the valency becomes stronger. Why it becomes stronger? Because the number of protons is increasing. Let's see the next question. That should be question number 7. Which of the following contains an ionic bond? Is it H2O, CH4, AKBr, or NH3? We know very well that in order to make an ionic bond, you should have a metal with what?
Mm. A non-metal.
A metal and a non-metal. So if you have a metal together with a non-metal, you will be having
KBR, sir?
sorry?
KBR?
Yeah, so the answer will be KBr. So in order to know the difference between the types, the most easy way to identify is to look, is it between a metal and a non-metal, or it is between what? So water, for example, is between 2 non-metals, right? H and O. And CH4 is the same also, H and O. What about this one? This is ionic. This is ionic because it is between metal, potassium, and bromide non-metal. What about NH3? Again, it is what? It's
H3 is a covalent.
covalent also, so it is incorrect. So the only one that's correct is the kPr, which has a higher first ionization energy. Is it sodium? Is it magnesium? Is it potassium? Or is it calcium? 1, 2, 3, 4. Which one of them has the highest ionization energy? Mister, I remember again as the ionization energy, as you move to the left, what happens, and to the right, what happens? Where is the highest ionization energy?
F.
F. So F, you go up and you go to the right, and even helium is even higher. So sodium or magnesium or potassium or calcium, let's check. Sodium or magnesium or potassium or calcium, which one has the highest one?
I think it's magnesium.
So magnesium will be having the highest one. So magnesium will be having the highest one. As I go up and to the right, it increases, right? So as I
Yes.
go to the right and to the up, it increases. That's why magnesium will be having the highest of them. This is the further right than sodium and higher up than calcium. And we know that it increases as I go up and to the right. Okay, let's see the next question, MCQ number 9. In an ionic solid, ions are arranged in a regular repeating pattern called, what is the pattern name in the ionic solid?
Crystal lattice.
Crystal lattice. Excellent. We said that the crystal lattice is the structure that has repeated and regular structure, right? We said it's called repeated structure and regular structure. The repeated and regular structure is called the crystal lattice. It's made from positive ions surrounded by negative from all sides and negative surrounded by positive. This decreases the repulsion and increases the attraction between the opposite charged ions. And that's, of course, is a very strong structure. Question number 10. So identify the most electronegative element listed, SOPC. So let's see again, the most electronegative element, sulfur, oxygen, phosphorus, and carbon. What do you think is the most electronegative element?
Okay.
Is it S, or is it O, or is it P or C? Don't forget that this is all available in the website. You can download the file of
O.
today and other files from it. SO.
O.
So O will be having a high electronegativity, and we know that the oxygen actually is one of the highest electronegativity elements. So, and I have like oxygen and nitrogen and fluorine one of the highest. So if I compare the carbon with fluorine and phosphorus and sulfur, I will see that oxygen has the highest one of them. The same reason as I go up and to the right, this is closer to the fluorine, which is the most electronegative element available in my group, my periodic table. Okay, which pair of atoms will most likely form a bond with the greatest ionic character? Is it C and O? Is it Na and Cl? Let's look at the periodic table again.
No. C
Is
and
it,
O, صح?
let's have a look. Is it C and O, or is it Na together with the Cl, or is it Cs with the F, or is it Mg and O?
C
Which
and
one?
O.
C and O. Why did you say C and O? We need to make it very ionic character. Very strong ionic character means it's between a metal and non-metal, right? You cannot make C and O ionic character because C and O are both non-covalent, right?
طب
Both
يبقى
are.
فيها ال
So it has
F. The one that
an
has
F.
the F.
Excellent. The one that has F. I have two here. I have one here to have F, which is CS and F. So that's very good because F has the highest electronegativity. So SF has the highest electronegativity, and we know that anything with F will be having a very strong difference in the. Why it's not doing? Trying to copy it. Yeah. Okay, so I know that F has one of the highest electronegativity values. It's almost 3.98 or 4, and cesium has a very low one. This is the lowest, right? So the difference between the highest and lowest most probably will give me the biggest difference in electronegativity. We call the delta N electronegativity difference. Okay. Question number 12 is asking, why is the lattice energy of magnesium +2 -2, which is higher than lithium, which is +1 and -1. So Mg is +2 and oxygen is -2, is bigger than the Li +1 and F, which is -1.
Higher charge magnitudes?
Excellent, excellent. So higher charges magnitude, because we said that the Coulombic forces, the forces of attraction between the two ions, depends on the charges. It's directly proportional to the charges and inversely proportional to what? You remember? It's inversely proportional to what? To the charge? To the radius, right? To the radius. The bigger the radius, the smaller the attraction. The smaller the radius, the bigger the attraction. So since the attraction is very strong, so the lattice energy is strong. What is the lattice energy? The energy that's required to break the bonds. So the energy that's required to break the ionic bonds is the strongest one. So again, I will say 1 and 1, the attraction is weak, but 2 and 2 is 4, right? Attraction is very strong. So the multiplication of the charges is stronger. And we said that this is directly proportional to the attraction. Okay, so according to the Coulomb's law, the charge is the dominant factor. And if the charges are the same, like if he give me LiF with sodium chloride, and in this case, I have to look at the other factor. What is the other factor? The radius. And the radius is inversely proportional. Radius is inversely proportional. Okay. So question number 13 in day 2 revision on a potential energy curve, if the bond energy or the depth of the well. What is the depth of the well? We said the curve looks like that. There is a low part and high part. So this is the depth of the well. This is my well. It goes down. It said increases. This means that the bond is longer and weaker, shorter and stronger, non-polar or ionic. Mister, you said that this is the distance. So this is x-axis is the distance between the two nuclei. The distance between the two nuclei. And this one is my potential energy. So if this one goes down, what happened to the potential energy? Mister, when you go deeper, it means there is more energy released when you make the bonding. So this, you go down, so this means more energy. So instead of -300 kilojoules, -400, -500. Why it is minus? Why it is minus, Mister? Why it's negative? Because it is exothermic. Why it is exothermic? Because it is bond making. We said before that making bonds is exothermic. When we said it is bond breaking, it's exothermic process. So it is, I said, it is endothermic, it's bond breaking. So when you break the bond between these two, there is heat is released. So the more, the bigger the number. As you go down, the number is bigger. So this means that the bond is stronger bond. So the bond is stronger, and stronger means short or long bond. It means a short bond.
Sure.
So let's repeat again. When you go deeper, when the well is deeper, so instead of heat, for example, it becomes here. This means that it is a stronger bond. So the distance is shorter. Like, for example, between nitrogen and nitrogen. This is a triple bond, right? A triple bond is a very strong bond. So it is a shorter bond. So if I compare the hydrogen, for example, bond, which is single, that's why it's a little bit weaker and longer distance. If I compared it to the hydrogen, you find that the nitrogen is stronger. That's why it's going downwards. This is very important in the exam, because many questions he will draw the curve for you and tell you about the difference between two elements. Why this one is deeper than this one? This one is deeper because it has a stronger bond. So stronger attraction means a deeper well. The more you go down, the more the attraction is there between them, that the more the bond is stronger. So if he give you a triple bond and a single bond, you will tell him this is the triple bond and this is single bond. What if there is a double bond? It will be in between. So the double bond will be in between. Why? Because it's weaker than the triple and stronger than the single bond. Next question, number 14. Which of the following is isoelectronic with Cl-? What is the meaning of isoelectronic? Isoelectronic means
They have the same number of electrons?
So have the same number of electrons. So if you have the same number of electrons, neon has what? Let's have a look at the periodic table because it will help us in this. So this is the periodic table. So this is a periodic table. This is the neon. We said something that has similar like Cl minus. Cl minus has
Argon,
how
صح?
many electrons? Yes, Cl minus has how many electrons? It has 17 plus 1, 18. So argon is the one, it's 18, correct. Neon is very far, that's 10 electrons. F minus is same like neon, it is 10. And Na plus is also 10, but these two are 18. So this is 18 and this is 10, it's not correct. And by the way,
الصب
which
هي
is
أقرب نوبل جاس ليها صح؟
exactly. That also helps. No, either by the number of electrons or by the closest. What is isoelectronic? Actually, the neon and F minus and Na plus, these three are actually isoelectronic to each other, right? They all have 10 electrons. They all have the same 10 electrons, but it's not our question. Our question is argon similar to fluorine minus 17. So let's revise this with the slide of it again. The neon has 10 electrons, argon has 18 electrons, and fluorine has 10 electrons, and sodium has 10 electrons. The chloride ion has 18, so this is the similar one. So this is the correct one, similar to it, the argon. Okay, let's see next question, which is question number 15. Why is the first ionization energy of boron lower than beryllium? And this is a very important question. This is a repeated question from day one. So this is a repeated question from day one. And the repeated questions are very important. That's why you will find them repeated many times. So let's see, beryllium, Mr. and boron. What happens to the beryllium and boron? Mr. I know that I will not explain this a lot because we explained in day one, but I will say it fast. The boron and beryllium, actually the boron should be having more or less ionization energy than the beryllium. More or less. I know that as I go to the right, the ionization energy increases. As I go up, the ionization energy increases. So it is similar in the trend. The trend of the electronegativity is the same as the trend of the ionization energy. Both of them the same trend. As you go up and you go to the right, it will increase. Very similar, right? They are similar, actually similar. So this means that the boron should be having a bigger ionization energy than the beryllium, right? Because you said we go to the right, the ionization energy increases. But in fact, the question tells me that the boron is lower. The boron is lower. So this means that this is an exception. This is an exception from the trend. There are two exceptions in the trend, always in the periodic table. The first exception happens between group 2 and 3. So let's say lithium is here, right? This is lithium. What happens to the beryllium? Beryllium is higher. So ionization energy increases in beryllium more than lithium. And it increases in nitrogen more than carbon. So nitrogen is higher than carbon. And it increases in fluorine more than oxygen. So in fluorine is more than oxygen. So what is the trend? What do you see the trend? It's coming up, right? When you go from lithium, to beryllium, to boron, to carbon, to nitrogen, oxygen, fluorine, to neon, what's happening? It's coming up, right? But there are two places where it goes down. Two places where it goes down. The first place is the beryllium and the boron. This is the first place. It goes down. So instead of coming up, it goes down. The second place between nitrogen and oxygen, it goes down again. So let me draw that. Again, it goes between first and second, it goes up. Between second and third, it goes down. Then third and fourth goes up. Fourth and fifth goes up. Fifth and sixth, it goes down. Six and seven goes up. Seven and eight goes up. So if you see, what is the general trend? Is it going up or going down? The general
It's
trend
going up.
it's going up as you go in the same group from left to right. This is not only in group 2, by the way, in period 2, it's on periods. So the same happens in the third, between Na and Mg and all. But there are two places where it drops, between beryllium and boron. So between group 2 and 3, what happened to it? It went down. And again, between 5 and 6, What does this mean? So between nitrogen and oxygen is supposed to be higher. Oxygen is supposed to be higher, but actually it is lower. And here, boron should be higher than beryllium, but it's actually lower. So there are two places. In another question, we are explaining between 5 and 6, but here we will explain beryllium and boron. What is the answer? Do you know what is the answer? The answer, you must do these three things in the exam. You must first write the electronic configuration. So let's see, boron and beryllium. Always draw the electronic configuration. This has 5 electrons and this is 4. This has 5 electrons and this is 4. So this is 1s2, 2s2, 2p1. And that one is 1s2, 2s2, 2. There is no 2p1, 2s2 only. So there are 2 electrons here and the same is here. And there are 2 electrons here and the same is here. And here there is 1 electron in the p and there is nothing here. So which electron you are trying to remove? You are trying to remove this electron. And here you are trying to remove this electron. Please do this in the exam, even if you are not asked. Why? Because if you fail to write this correctly, then the drawing will help the examiner to understand that you know what you are talking about. You are trying to tell him that it is easier to remove the electron from the 2p1 than removing the electron from what? From the 2s2. So why? Because the 2p subshell has higher energy than the 2s, which means that it is easier to remove. It's easier to remove. Has high energy, right? It can be easily taken out. But if you have low energy, it's very difficult to make you move. So what I will write typically in the exam, number 1, draw it. You must draw it. Second, tell him from your drawing, this one has higher energy than the electron here. So it's easier to remove the 2p1 electron than removing the 2s2 electron. Why, mister? Why? Because this has higher energy, so it has higher energy. And what is the second thing you will tell him? You will tell him the 2p1 is more shielded, These electrons in the 2s makes a small subshield. They make a subshield. What does the subshield do? They make a difference between this electron and the nucleus. So we said in the same group there is no difference in the shielding, but there is only a small subshielding. So summarize the answer. Draw them. Write the configuration of this one and this one. Tell him it's easier to remove the 2p than the 2s, and say that why? Because it has higher energy. So it has higher energy, and the 2p1 is more shielded. What happened if he, instead of saying beryllium and boron, he said aluminum and magnesium? I will do the same. But instead of saying 2p1 and 2s2, it will become 3p1 and 3s2. What if it is in the next 4p1 and 4s2 and so on? So this will help you answer clearly and easily. And again, it's happening between all group 2 and group 3. So if he said calcium and gallium the same, strontium and indium the same, barium and titanium the same. Okay, what is the second exception? It's between group 5 and 6, but we will not explain this now. We explained it yesterday in the file number 1. And if it comes again, we'll explain it again. This is one of the questions that's repeated because it comes a lot in the exam. Question number 16. Hopefully we can finish all the 20 questions today. Which solid will not conduct electricity in the solid state, but it will conduct electricity in the dissolved in water? We just explained. This is what?
Ki.
Ki. Very well, because Ki is a ionic.
Ionic.
Because Ki is ionic, and we said that ionic can conduct electricity
Conduct in molten or aqueous.
in the molten form and in aqueous form. Excellent job. So again, what is the ionic solid? Ionic solid is made from ions, solid form, very close to each other. They cannot move. So how can you expect this one to conduct electricity? In order to conduct electricity, you should be having moving charges. And these charges are not moving. That's why they don't conduct. The ions are fixed in their place. What about this one in the water? Now it's moving, right? It conducts ions freely to move. They are conducting the ions freely to move. What about the the sugar. Why we did not pick sugar? Sugar
This is
is
covalent.
molecular. It's covalent. It's molecular. It does not form ions, so it has no charged particles. Here the particles are there, but moving only if aqueous. But here no charged particles at all. What about the other options? The SiO2 quartz, also the same. It has no free charges, and the copper is metallic. It will conduct electricity even if it is solid. So this one conducts if it is solid. That's why it is wrong. He said only in the aqueous, not in solid. That's why I could not pick the copper. A bond between nitrogen and hydrogen is non-polar covalent, polar covalent, ionic, or metallic?
Polar covalent.
Polar covalent. Excellent. I know that this is polar covalent, and the proof is that this is a very strong bond. This is a very strong bond. Even the hydrogen bond is strong because it has this bonding, right? It has partial positive and partial negative. Big difference in electronegativity. This is 3.04 and this is 2.20. So they are both nonmetals making covalent bond. Nitrogen is very electronegative. That's why the difference is big, and it is polar covalent. Anything that comes with the nitrogen, with the oxygen, with the fluorine, with the chlorine is mostly a polar covalent bond. The next question is asking number 18. As you move down group 2, the reactivity of the metals, is it increasing? Is it decreasing? Does it stay the same? Or it depends on the temperature? This is not a common question to be repeated, so it's nice to know. The metal reactivity, it will increase actually. It's the same like in group 1. Why it increases? In order to be reactive, what will the metal do? Metals do what? Metals are good in doing one thing only. Doing what?
Losing.
Losing electrons. Okay, which is easier to lose the electrons? If your electron is closer to the nucleus, or your electron is farther away from the nucleus, which will be easier to lose it?
Farther from the
Farther
nucleus.
away. And where do you become farther away from the nucleus? Down the group or
As you go
up?
down.
As you go down. So as you go down, the electron becomes further. You can easily lose the electron, so the reactivity is gonna increase. So the reactivity is gonna increase. So the metal reactivity trend down in group 2 is that it increases down the group. Why is that? Because large radius means the valence electrons are further away from the nucleus, making it easier to lose the electron. So ionization energy decreases, and it's very easy to remove the electron. Okay, next question is question number 19, and it asks which factor contributes most to the brittleness of the ionic crystal? Is it the delocalization? It's C. The repulsion between like charged ions is very good, because we said once you get the structure to move and slide, the ions are having the ions that have the same charges are gonna come close to each other. You align the plus with the plus, with the minus with the minus. So this causes sudden repulsion, which shatters the crystals and make it break down. Very good. Number 20. Which bond is the shortest bond?
Coulomb equal.
The shortest is the strongest, right? The shortest is the
strongest.
And the strongest is which one?
Triple
bond. Excellent. So the triple bond is the strongest bond. It shares more electrons. That's why there is stronger attraction. And when there is stronger attraction, the difference between the nuclei, or the distance between the nuclei, becomes the smallest, which is the shortest. While this one is the longest and the weakest one. This one is the longest and the weakest one. That was the end of the 20 MCQ questions. After that, we have FRQ questions, but we don't have enough time today. We'll be doing it in another part.